When you have a problem like this, negative 5x plus y equals 2, and I want to graph it. We showed you last time how you can do the x-intercept and the y-intercept, or by picking points. Another way of doing it, and I think we looked at that too, is by rewriting this problem, put it in the form of y equals mx plus b. And why we like that form? Because once you put it in that form, you know what the slope, which is m, and you know the y-intercept, which is b. So if I take this equation now and solve it for y, that will tell me what? Y equals, when I take the negative 5x to that side, remember, change side, change sign, becomes what? Positive 5x plus the 2. I don't need the plus in the front. I'll just write that 5x plus 2. Again, I know two things now. I know my slope equals 5, or I can write that 5 over 1. Why do I want to write that 5 over 1? Because what's the definition of slope? Rise over the run, exactly. Or change in y, that's what the rise over the change in x. And my y-intercept is equal to 2. These two things, I should be able to graph it. So my y-intercept is what? 2. That's this point. And now let me look at the slope. The slope is 5, or 5 over 1. What this one is telling me, if you increase, because that's a positive, if you increase x by 1, you have to increase the y value by what? By 5. So let me increase x by 1 and increase y by 5. 1, 2, 3, 4, 5. That's where the second point will be. Go 1 to the right and 5 up. Notice if you make a triangle here, this is 5 and this is 1. You go 1 to the right and 5 up, and you end up with your second point. Once you have these 2 points, and if you connect them correct, they should make a straight line. Any 2 points will make a straight line. Here's the problem when you only pick in 2 points. If you make a mistake, there's no way of catching it. With these two, there's no way. So maybe what you want to do is take a point and just a third point yourself, just to make sure it really lies on the line there. And if I look at this, it's not steep enough, but if I graph this on a graph paper, it will work out nicely. Let me just get a ruler here. If I use a graph paper and I connected that, let's see. Let's try it and see if that works out nicely. This is the y. Let me find the x-axis. We said the y-intercept is 2, right? That's this point. And go 1 to the right and 5 up. 1, 2, 3, 4, 5. That's this point. So when you connect the 2 points, that's the graph. Now, as I said, if you want to make sure you got it right, pick a point, like when y equals, here we go, 5x plus 2. Pick a third point. For example, when x is negative 1, what's the y value according to that equation? y equals 5 times the negative 1 plus 2. What's 5 times the negative 1? Negative 5 plus the 2, which is what? Negative 3. So when x is minus 1, again, I'm not really good with this. I'm a little bit off there because there's the 1. So I'm a little bit twisted to the right, but close enough. See that point? So I bet you if I twisted the line, so it's almost on the line. That's because I'm a little bit crooked there. I can see my axes, my y-axis. I don't know if you can see them. Don't line up on the blue line. But that's one way to see if you actually correct. You pick a third point. But with 2 points, if you make a mistake with either one of them, there's no way of catching that. That's the only drawback to this method. But we're going to use that method. So we've shown you 3 different ways to graph it. Again, once you get to this point, another way of doing it, if you don't like this method, is you pick points. You can just pick values for x and find the y value that goes with it, and connect the points and see if they make a straight line. I'm going to mix and match. I'm going to do all, actually, 3 ways of each problem. Kind of review what we did, plus bring this one in. So I'll take another example. I'll do it multiple ways. One way of doing it is by doing the x-intercept and the y-intercept. If you missed the class last Wednesday, that's what we did. What was the x-intercept? What do? You let what? Y equals 0. And what was the y-intercept? Let x equals 0. Very good. Well, if you let y equals to 0, you have 3x equals what? 6. X will be what? 2. To find the y-intercept, we let x be 0. That means the x piece is gone. 5y equals 6. Y equals what? 6 over 5, which is what? 1.2. Again, if I'm graphing this, here's the problem with these now. X is 2. Where's the 2? Right here. That's an easy one, right on the dot. But what about the y equals 1.2? Where's the 1.2? Your guess is as good as mine. A little bit more than 1, I know that. But is it really this point? Is it higher? Is it lower? So it becomes like a neighborhood. So in a case like this, they might give you a lot of graphs of which one looks like yours, because it's tough to pinpoint where's the 1.2. And that'll be the graph for it. So that's what we did last Wednesday. We graphed by finding the x and the y-intercept. I said to you before, I am a fan of this method when I have x and y on the same side, like this problem. I'm a big fan of this method. I find the x-intercept, I find the y-intercept, and we connect the 2 points. And again, to find the x-intercept, you let y be 0. Once you let y be 0, this whole term is gone. 3x equals 6, x equals 2. To find the y-intercept, you let x be 0. This whole thing is gone. 5y equals 6, y equals 1.2, and you connect them. The other way of doing it is solve for y. And do it 3 different ways. It's the same problem. You'll see solving for y probably not the best choice here. And when you solve this for y, that means you got to move the 3x to the right side and change side, change sign, So you'll have 5y equals negative 3x plus the 6. We take the 3x there, it becomes a negative 3x. Now I want to solve for y. To solve for y, you got to divide this side by what? By 5. I can do like this, the whole thing. So y equals negative 3x plus 6 over 5. Or if you want, you can break it down to two parts. Negative 3 over 5x plus 6 over 5. Either way. Let's look at the method we looked at last Monday. Wednesday we did the x and the y-intercept. Monday we said one of the easiest way to graph is by picking points. So if I take this one and I pick values for x, I make a table. Maybe I'll use 0, maybe I'll use 1, then 2. When x is 0, what are you going to have? What's negative 3 times 0? 0 plus the 6 over 5. What is that? 6 over 5, which is 1.2. When x is 1, what's negative 3 times 1? Negative 3 plus the 6 over 5. That's 3 over 5, which is what? 0.6. When x is 2, what's negative 3 times 2? Negative 6 plus 6 over 5, which is what? 0. Again, if I connect these points, zero and 1.2 somewhere here, 1 and 0.6 somewhere here, 2 and 0 somewhere here. And notice they do make a straight line, so when you connect the 3 points, that's the graph I'm looking for. Does that look like the other one? Look at this graph. Same thing, except my scale is bigger here. Today's method is I want you to graph it using the slope-intercept, the same equation, which means I got to use this one. That's what I got to use. I got to use the information right here. So this is what section actually 4 talks about. How do you graph it? By using this information, the slope and the y-intercept. It will be the same answer. Again, y equals negative 3 over 5x plus 6 over 5. That means I know two things. What do we know? We know the slope and we know the y-intercept. What is the slope? Yep, negative 3 over 5. And what's the y-intercept? 6 over 5. So this is the change in y over the change in x. Now I can see that better if I use graph paper. Let's graph it. Let me begin with the y-intercept. 6 over 5. That's a little bit more than 1. That's a 1.2 again. That's somewhere here. Now my slope, let's look at the slope. It says if x increases by 5, the y value has to do what? Decrease by 3. Let's go 5 to the right. 1, 2, 3, 4, 5. I'm right here. Now let me go down by 3. 1, 2, 3. Go 5 to the right and 3 down. Connect the 2 points. So this is 5 here, and this is -3. It went down 3 units. And now we get the same graph. Notice we know it's the same graph. When x is 2, what's the y value from this picture? Isn't it 0? Let's look at the other two. When x was 2, what was the y value here? 0. The other method, we did the x and y intercept. When x is 2, what was the y value? 0. So it's the same graph. It doesn't matter which method we use. My answer is not going to change. Cut this paper. I'll do another example with the slope-intercept form. Take a snapshot. I'll have this picture there. Okay, so we know the slope-intercept form. Let me take one more example on that. And y minus 1 equals 5 times x minus 1. We have that equation. Doesn't look like anything we covered yet. The form itself, I mean. This actually has a name. I know what that form is. I'll mention it in a few minutes. But if you're given a problem like this and you want to graph it, first thing you want to clean it. You need to distribute that through. Y minus 1 equals what? 5x minus, what's 5 times 1? 5. Move the minus 1 to the right side. Again, change side, change sign. You have what? Y equals 5x. What's minus 5 plus 1? -4. So this does not look like the slope-intercept. This is the slope-intercept form. Again, the reason we call the slope-intercept, because we know what the slope equals what? 5 or 5 over 1. And that's the change in y over the change in x. And the y-intercept is what? -4. I can do over 1. I don't need, I just need the slope to be a fraction, so I know which one's which, the change. We're going to graph it. The y-intercept is -4. That's right here. Now, let's do that slope. It says increase x by 1, increase y by 5. Go 1 to the right and 5 up. 1, 2, 3, 4, 5. 1 to the right and 5 up. Connect the 2 points, and that's the graph of that. I put this equation in a funny look there. That look actually is called the point slope, not the slope intercept, the point slope. What does that mean, the point slope? Sometimes the equation is written like this: y minus y sub 1 equals m times x minus x sub 1. And that's really what we have. Y minus y sub 1 equals some number times x minus some number. This is called the point slope form. Y, it gives you the point and it gives you a slope. The slope is equal to x1 comma, that's the point. The slope is m and the point is x1 comma y1. So if you're in this form, you know one point, you know the slope. Now let me go back to this equation. This is my x sub 1. Well, without the minus sign, because the form is x minus. This is my x sub 1, and this is my y sub 1. Notice, try to match it with the one above it. When you compare the two of them, if you look at them, you get the y and the y, the minus and the minus. That means this number is y sub 1. This number must be what? M, the slope, parentheses, x is x, minus is minus, and this number is x sub 1. That means I know one point, which is 1 comma 1. That's the point. And I know the slope, which is 5, or 5 over 1. The difference between this and that is it's not the y-intercept, is you know one point. A point, any point. It's not where it intersects the y-axis. So when I graph that, I have a point. The point is 1 and 1. That's this point. It's not the y-intercept. It's just a point. And it could be anywhere. And now the slope is 5 or 5 over 1, which means go 1 to the right and do what? Go 5 up. So this point is right here. So you have a point, but it's not the y-intercept, and you have the slope. So that's called the point slope form. You can still graph it if you're in that form without having to solve it for y. A lot of times they ask you to put it in this form. It says, you know what? We have a line, with the slope equals -2 and passes through -1 and 5. So what they might ask you to do is says, you know what, given that, can you find the equation of the line? When you hear the word find the equation, when you see find the equation, a flag should go up in your head. It's, wait a minute, wait. To find the equation, I need to use this. Y minus y sub 1 equals m times x minus x sub 1. That's what you want to use. Anytime you see the problem says find the equation of the line, I need to be thinking about that one. But to use this one, to use it, you will need 1 point and the slope. You will need 1 point and the slope. Do we have 1 point and the slope here?
Yes.
Yep. So the point actually gives you the x value, that's x sub 1, and this is y sub 1, and the slope gives you the m. So if you come back now, you plug in these numbers in, what do you have? Y minus, what is y sub 1? 5 equals the slope, which is -2. X minus, what's x sub 1? -1. What's a minus minus 1? Positive, good. And now if I leave it like this, again, it depends how they want the answer. They're specific on the software. If they said leave the answer in the point slope, you stop right here. If you go beyond that, they'll mark it wrong. So if they said give the answer in the point slope form, stop here. If they said give the answer in the slope intercept form, that means you got to continue. You can't leave it like this. So if they ask you for the slope intercept form, this is not acceptable. How do we change it? We're going to distribute that. That's -2x minus the 2. Can you move the -5 there? When you change side, you change sign, that becomes what? Positive what? What's the final answer? Well, -2 plus 5, which is what? +3, right? And that'll be the slope intercept form. So if they say find the equation of the line, boom, you're going to be thinking about this one. That's the one to use.
The other one's just solved.
And after that, just simplifying it. Here's the problem. A lot of times they're not going to be that nice to you. Which means what? They're not going to give you the point and the slope. So I'll be a mean guy and I'll give you this problem. Find the equation of the line that passes through somebody pick a point for x and give me a value for x and y. Was it 1 and 4? And somebody pick another point. 2 and 8. Not a good choice he gave us, but we'll see. I mean, it's not bad, but it's actually okay. What's the question? Find the equation. Then I should be thinking immediately using this one, y minus y sub 1 equals, I left a space for a reason, leave a space, and to use that one, we said you need what? You need 1 point and the slope. Do we have 1 point?
Yep.
We got 2. We're lucky. So this is x1, this is y1. This is x2, this is y2. So we do have x1, y1. But do we have the slope? No. So I can't solve this, I don't know what the slope is. So what can I do? How can I find the slope?
And X.
Solving with the points.
Use these points, you mean? How?
Y x1
How about y2 minus y1 over
2 minus
x2 minus x1, section 3.2, the slope. y2 minus y1 over x2 minus x1. y2 is what? 8 minus, what is y sub 1? 4. What's x sub 2? 2 minus 1, which is 1. So what's 8 minus 4? 4 over 1. Now I get everything I need. Y minus, what is y sub 1? 4 equals the slope. When I said it wasn't good, I was hoping for some ugly numbers. So this is 4 x minus, what is x sub 1? 1. Again, if they say leave your answer in the point slope, we're done. That's the point slope form. If they say go beyond that and clean it, that's 4x when you distribute that, minus the 4. When you move the negative 4 to this side, what do you have? 4x minus 4 plus 4, which is 0. You're not going to write plus 0. There's no need to write it. So this is really the point, slope, intercept. The slope intercept form. Now if notice what's the slope, what's the intercept here, by the way? What's the y-intercept? 0, sure. Because that's what 4x plus 0. We just don't have the 0 there. They could even make it worse. What do I mean by worse? They're not going to just give you straightforward a point and a slope. I can guarantee you that. They'll give you 1 or 2. But they might give you a problem like this. I'll try to mix everything that we learned. Find the equation of the line. That passes through and I'll make a point, doesn't really matter, I'll pick a point, 3 and 5, and perpendicular, we talked about that word, perpendicular to 2x plus y equals 7. Couple of key things here. My first one, find the equation. Leaving a space there. I said, I know what I have to use. I have to use y minus y sub 1 equals m times x minus x sub 1. That's what I have to use. I need 1 point on the slope. Need what? 1 point. Do we have a point? Yep, check. That's x1 and y1. Do we have the slope? No, not yet. We don't have that. To use this, I'm going to need both of these. I have this, I don't have that. Here's the other side of the problem. This is perpendicular to this one. Would be nice if this is parallel to this one. Why? If they were parallel, that means they have the same slope. So if I know the slope to this, I know the slope to my line. This doesn't say parallel. Do we know the slope to this one?
No.
Well, think again. Let's look at this. Do we know the slope to this one? Almost. Nope. What is it?
Negative
Negative what?
2x.
Not the 2x, negative 2. You need to solve this for x to get the, for y to get the slope. Y equals what? Negative 2x plus the 7. The slope is the number without x. The slope of this line is negative 2. Or negative 2 over 1 if you want to. But that's not our slope. Our line is perpendicular to this. Our line is not this one. It's perpendicular to this one, which means our slope is going to be what?
2.
If they were parallel, it would be negative 2. Perpendicular. How do we find the slope of that perpendicular? Section 3. Flip and change the sign. Remember that? You take this, flip it, and change the sign. So it becomes positive 1 over 2. For two lines to be perpendicular, if you take the two slopes, multiply them, the result is minus 1. So the only way to get a minus 1, if you flip this one and you change the sign. Now if you multiply the two numbers, that's a minus 1. So always if it's perpendicular, flip, that's you, and change the sign. Again, if it says parallel, they'll be the same slope, they'll be minus 2. But perpendicular is not the same slope. So now we know that one. Plug it in. Y minus 5 equals the slope, which is what? 1/2 x minus 3. Again, this is the point slope form. Now, if I want to simplify that, one half x minus what? 3 over 2. When you multiply a fraction, the top times the top, the bottom times the bottom. Take the minus 5 to the right side. This becomes 5 plus 5, or 5 over 1. How would you add these two numbers? Yep, common denominator, which is what? Which is 2. What's minus 3 plus 10? Is that 7 over 2? So the final answer is 1/2 x plus 7/2, and that's your slope intercept. Intercept form. That's the slope intercept form.